Change the order of integration for double integral I equals integral 0 to 4a integral x square by 4a to 2 times root of ax dy dx. Here we have been given the order of integration such that integration with respect to y is performed first and then we perform integration with respect to x. Since we are asked to change the order of integration, we have to find out limits of x in terms of y, or limits of x need not be constants, and then we have to find out the limits of y which must be constants. Since we are asked to change the order of integration from dy dx to dx dy, we will have to consider horizontal strip and then allow it to slide across the given region of integration. Let us find out the boundaries looking at the double integral given. We have y changes from y equals x square by 4a to y equals 2 times root of ax, which means that region over which we have to perform integration has y equals x square by 4a as the lower boundary and y equals 2 times root of ax as the upper boundary. We have y equals x square by 4a can be written as x square equals 4ay, which is this parabola, and we have y equals 2 times root of ax when squared on both sides will give us y square equals 4ax, which is this parabola. We have these two parabolas are the boundaries which intersect at 0, 0 as well as at the point 4a, 4a. For the given integral, since integration is carried out with respect to y first, they have written the limits considering vertical strip. When you consider a vertical strip, you can verify that the lower bound of the vertical strip is at x square equals 4ay, which is the lower bound of y here, and the upper end of the vertical strip is at the parabola y square equals 4ax, which will give us y equals 2 times root of ax. Y equals positive 2 times root of ax correspond to this positive branch of the parabola. Our objective is to change the order of integration. That is, now we will consider a horizontal strip so that we will have integration with respect to x performed first. We have drawn a horizontal strip here. We have the left end of the horizontal strip is at this parabola, that is y square equals 4ax. From this equation of parabola, we have x equals y square by 4a, which becomes the lower bound of x. We have the right end of the horizontal strip is at the parabola x square equals 4ay. That is, this parabola will give us the upper limit corresponding to variable x. From the equation x square equals 4ay, we have x equals 2 times root of ay, which corresponds to the upper limit of variable x. Therefore, x varies from y square by 4a to 2 times root of ay. Now we will have to allow this horizontal strip to slide across this region in order to trace the complete region over which we perform the integration. Horizontal strip must be allowed to slide from position 0, 0 to position 4a, 4a, so that the entire region will be traced. That is, this horizontal strip shrinks to a point 0, 0, then it enlarges and finally again shrinks back to the point 4a, 4a in order to cover the complete region over which we perform the integration. Therefore, limits of y will be from y equals 0 to y equals 4a. Notice that limits of x are non-constants and limits of y are constants. Once we have found the limits correctly, we can perform integration easily. When you carry out integration with respect to x, y will be treated as constant. We have integral dx equals x, to which we will give upper and lower limits of x respectively. We have obtained the integrand in terms of y. Finally, we will perform integration with respect to y. On application of upper and lower limit, we obtain the given double integral has the value 16 by 3 times a square. You can verify that even if you had evaluated the double integral following this order of integration, you will arrive at the same answer.